Welcome back to XSOAR Engineer Training. This is part 7, building the playbook. Now in this video, we're going to be building out the playbook for our use case, covering some of the following topics. Various tasks, including using automations and integrations, built-in commands, conditionals, manual tasks, etc. Perform field mapping on task outputs, use advanced task options, and even test our playbook via the Playbook Debugger. Now at the end of this video, our playbook should be doing the following. First, it's going to retrieve the user details from Active Directory. We're going to check if that user is an executive or administrator, escalate severity as required if they are. Check whether the user clicked from an internal or external IP. Check if any indicators are malicious, and if so, we'll automatically proceed to remediation, or we'll ask an analyst to review and choose the direction they want the incident to take. Lastly, we're going to block the URL and reset that user's password if remediation is required. And with that, let's get to it. All right, we're back in XSOAR and we've got our blank playbook ahead of us so we can start building it. Remember to please watch video 6 as we cover playbook essentials as to how these tasks work. Let's get started. We're going to add our first task, which is going to look up the user in Active Directory. Give this a title which is descriptive to how the task or what the task is doing. So look up user in Active Directory. For this, we're going to be using our AD get user command from the Active Directory integration, picking the one in brackets. And this integration takes a number of different options. Now from our mapping video, we took the source username, which was an email address. So we're going to be passing that from the incident object into this particular task. Hit the blue button, we can search for source username. And we can get access to that particular field from within the incident. Now one very useful feature is the ability to test that what we're getting is what we expect. For this, we can hit filters and transformers and tell it to get the source username from the incident object. And we can hit test, which allows us to check an existing incident to see what information is stored there. So for example, we can click from here and we can see that we have a couple incidents that are available to test against for our URL allowed. Select that and hit test, and you can see we get back the username from the source username field, which indicates this is what we want. Try it from the other one and get the one for James Bond. So be aware that as you're building this out, use the test function to make sure that what you're getting, if you're pulling it from incident data, is what you expect. You can hit done testing here, hit OK. And now we're telling this command to grab the email address from the incident source user field, and we know it works because we tested it. Next, let's use field mapping to take the outputs or some of the outputs from this task and place them into incident fields for easy use from our analysts. If you remember back to our layouts video, we put fields on the layout to hold the user's SAM account name in the event it's different, even the group memberships that they're a member of. Now we might want our analysts not to have to look in context for these or review the war room entry, so we can put them into fields, and we can do that via the mapping tab. So for this, we can go and click Add Custom Output Mapping. We can select the output that's coming from this task, in this case the SAM account name, and tell it to put it into the SAM account name field. We can do the same thing by selecting the member of, and let's put that in the account groups field that we added to the layout. We can hit OK, give our playbook a quick save early and often to make sure we don't lose our work, and then we can actually test this task via our Playbook Debugger. All right, to test our playbook, we can open up the debugger panel. We have the option to test against a mock incident, which has no data at this moment. We can also test against existing incidents like the one we pulled in, which means that we can use the information from within that incident, such as the source username. In this case, we'll use the new mock incident, and we're going to override the input. This is a nice feature of the Playbook Debugger. We can actually override this and hard code it just for testing to allow us to just pull information about a particular user. So we'll use James Bond, we'll hit OK, we get the little flag that shows the inputs being overridden. Let's give this a run with our Playbook Debugger and see how. Taking a look at the task, we can see we have the results. However, they're not marked as a note. That might be something we want to configure via advanced options, so it's highlighted in the war room. You can see the inputs that this task was used, so the email, and then the outputs it generated. and we can review these in context. We can also check the SAM account name that we mapped via field mapping and see how that looks. In this case, we have it, but we can see that it's in a list format. Let's fix that in a second. And we can even check the account groups and see how that looks as well, seeing that we have the groups here. Now the user might be a member of multiple groups, so maybe we'll leave this as a list. Let's hit stop. Let's fix a few of those issues before we move on. Let's start. Let's mark this as a note. This might be important information for our analysts to use, so we'll go click on the task, go to advanced, we'll hit mark as note. Next, let's take a look at the field mapping, and let's change that to a single string versus having it come in as a list. In this case, we'll switch to field mapping. Let's click the blue curly brace. Let's do some filters and transformers on this information. Click filters and transformers, and we need to tell it what it's going to be filtering and transforming on. In this case, the SAM account name. And let's stringify this so that it comes in as an actual just string versus the data in a list. Click this, we'll search for stringify. For any of the transformers, you can always highlight over them, and it should give you a description as to what this transformer may do. We can hit OK, save this. Okay, we can run our playbook one more time through the debugger and see how that looks. Let's search for SAM account name again. Okay, and we can see now that the SAM account name is no longer in that array format. It's just been stringified to this single element. That looks a lot better and will present nicely to our analysts. Let's hit stop. Let's continue. We'll close our debugger panel. Remember, as XSOAR engineers, use that debugger to help you build out the playbook as you go. It's very useful and can help prevent or catch errors as you're building it out. For now, let's click Save Playbook. Let's add the next task, which is going to be a conditional. In this case, we want to check whether or not our user is either an administrator or an executive. We'll do this using the groups because that's what's coming from our data. But in this case, we're going to create a conditional task and give it a name in the form of a question. Is the user an executive administrator? Now, conditionals can be used to branch our playbook to take them down different paths based on the information we have available to us. In this case, we want our conditional to check whether or not the user is an executive or an administrator and escalate the severity if they are. For our conditions, we have the option to provide multiple conditions to take it down different paths if they match. For us, we only need one, and we can use the default, which is a condition for yes, or we can change this name and we can call this VIP user if we'd like. In this case, we need to provide the condition for which this will match. We have the outputs from previous tasks available to us, and we're going to select this. We'll pull the outputs from our Active Directory user lookup and look at the member of field. In this case, we want to check whether or not the member of either contains the word administrator or executive, as those are the groups in our Active Directory. For this, we can specify our qualifier. For example, in this case, we want to use an includes. So we can search for it, select it, and we can also note that we can tell it to ignore case because things by default are case sensitive. That might be our use case here. So we'll do ignore case, and we'll include the word administrator. And we can add either an and, or in our case, we want to do an or, and we can do that by clicking the plus sign. We use the same thing, or the member of, and this could be includes once more. And we'll make sure to ignore case, includes executive. Hit that, and that's our condition for yes. If we want to add other conditions, we can do that here as well. We only need one, so we can hit OK and add our next task. From our conditional, we just click the half arrow. Creating a new task prompts us with the conditions that we specified. In this case, we can build out the branch for if it is a VIP user. We'll select that. And if it's a VIP user, all we wish to do is escalate the severity on this particular instance so our SOC is aware. So we'll do set severity to high. And for this, we're going to be using a built-in command that you may be using quite a bit. It's called set incident, and it sets incident fields. And select it from our automations list. And then we can add as inputs the various fields that are available to us on our instance. In this case, we're looking for severity, so we can search for it. And one thing to highlight as you're building out any playbook is use the tooltips. You can see here that we have severities for critical, high, medium, low, informational, etc. But the playbook is expecting us to set these in the form of a number. So to set this to high, we actually need to set it to 3. Do that, hit OK. And then if they're not a VIP user, we need to give our conditional a way out. For this, we can add another task, right? And we can use the else case. As you're building playbooks, this is important. You need to make sure that either your conditions are guaranteed to match, or if not, give it a way out or it will stop on error. So in this case, we can give it an out using the else case, and we'll do set severity to high to medium. We'll use our set incident one again, just by searching for it. Severity. Okay, hover over, and medium is a 2, so we'll set that to a 2 and hit OK. Save our playbook, again, save early and often, and we can give this. We can pop open our debugger panel. We're still using the overridden input for James Bond, but let's give this a run. Comes through, grabs the details, hits our conditional, and sets the severity to medium. We can make sure we got our conditional right. If James is not an executive or admin, he shouldn't have that in here. But you can see that he's actually in admins, so we can actually adjust our conditional before we move on. Again, highlighting the importance of using the debugger to test as we go. We'll hit stop. We'll go back here. We'll change this to admin and move on. That should catch both administrators and admins in our use case. Hit OK. Save our playbook. Check it one more time. And you can see now it sets it to high. For now, let's hit stop. We're going to close our debugger panel. We'll come back to debugging when we're done building things out. Next, we'd like our playbook to check whether or not the IP the user clicked from was either internal or external to our network to save the trouble for one of our analysts doing that manually. We'll add a new task, and we can link these both to that same task. This means that no matter which way our conditional went, they'll both hit this task either way. For this, we're going to give it a name, check if source IP is internal or external. We'll use an automation from our automations library called isIpInRanges. This one takes a source IP and then compares it to a list of IP ranges and returns whether or not it was internal or external. For this, we know that the IP is in the source IP field because we did that via our mapping video. So we'll grab source IP. And then by default, it will use the internal IP ranges, the 172.16, 10.192.168. But this is a good opportunity to talk about using lists within an XOR playbook. Now, XOR lists are useful for playbook development, and then they can hold data that is external to the playbook. In this case, we could hard code our internal IP range, giving it the 10.CIDR range. But if this list were to ever change or we added a new range, it would mean we'd have to come back into the playbook and know where we use this automation across all of our playbooks. Better practice is to use an XOR list to hold this information and then bring it into the playbook. That way, if we ever have to add a range, we can simply update the list and it'll apply to anywhere we use it. So let's take a look at how we do that. First, we're going to hit OK to save our work. We're going to save our playbook, and then we're going to exit out of here. Go to Settings, Advance, and Lists, and we have the opportunity to add a new XOR list that we can then use and reference within our playbook. Click New List, call this Internal P Ranges. We can create lists of different type. In this case, text is fine, and we can give it our list of IP ranges. Use just the 10 dot, but if we had other IP ranges that we were going to use, right, we could specify those as well. In this case, all of our ones are coming from the 10 dot range, so we can hit save. We can go back to our playbook and use this list as a playbook input. That way, if we ever have to change anything, we just update the list. Get out of here, go back to our playbook editor, and we'll edit our URL playbook. Go back here. We can now add the list as an input. If we click the blue buttons, you can see we now have lists. We can pass in our internal IP ranges as an input to this particular task, which means that if we ever need to again add a range, we can add it to the list, and it'll apply no matter where we're using it. So one good things about Xor lists is they're external to the playbooks, but they can still be used as inputs as well. Hit OK, give our playbook a save, and we'll continue. Next, let's use a combination of field mapping as well as a filter to set the IP address to the detected internal or detected external IP fields, depending on the results of this. Let's go back into our task. We'll go back to the mapping tab, and we'll add a mapping. Click for the outputs, and we'll click filters and transformers to allow us to set things based on a condition or a filter. So in this case, we would like to set the IP address that comes out of this to the detected internal IP ranges field if it's an internal address, or set it to external if it's external. So in this case, we'll have it grab the IP.address output, and then we'll add a filter to this to set it based on the condition. So for example, we'll do it if the IP.range output is equal to yes. Then we'll set our detected internal IP field. So hit OK, and we're going to set detected internal IPs. Do the same thing. In this case, we'll grab that exact same output using filters and transformers. So we'll grab the IP address, and we'll grab the filter where if it's not in the range, so IP.inRange is equal to no, we'll set the detected external IP field. Okay, in this case it's detected external IPs, and we'll hit OK. So you can remember to use filters to select data from context or from the inputs or outputs depending on your use case. We'll give this a save and we'll move on. Next, let's have our playbook check to see if any malicious indicators were found as part of the enrichment that was done on incident ingestion. Remember back to that video, we told for this incident type for it to extract URLs and domains and IPs from the fields that we mapped and enrich them in line with threat intelligence. So for this, we're going to add a new task. We're going to be using a conditional task, and this particular conditional runs as part of an automation script. The one we're interested in is called Is Malicious Indicator Found? We can highlight over the tooltip to see what it does. In this case, it's going to look at the indicators that are associated with our incident, and will return yes if at least one malicious indicator is found. For this, we can look at our options. We can see that the include suspicious defaults to no. We're going to err on the side of caution. We're going to say if there's a suspicious indicator, we'd also like to consider it malicious. Hit OK. Give it a name. Any malicious or sus found. And then we can build out the path that follows this particular automated condition. To start, let's build the path for yes. We'll drag it out. You can see that we are presented with the two options that this conditional will return. Now in this case, we don't need an else because it's either going to return yes or no as it's coming from our automation script. So we'll start with the yes path. We'll hit save. Let's use a section header to hold this section. In this case, we're going to move on to remediation because something was found as bad. So we'll call this remediation, and we'll just use a section header to hold our playbook. Now, in the event that nothing is suspicious or malicious, we're going to want our analyst to review this incident and decide which path it should take. So we'll add the no path, click no, and in this case, we're going to want to use a manual task for an analyst to review this incident. Now this defaulted to a manual task, which requires the user to complete the task to move the playbook along. However, this is a good opportunity to talk about manual conditionals. Let's select conditional and turn this into a manual conditional. Now a manual conditional allows the analyst to choose which direction they want the playbook to take. In this case, we're going to be asking our analyst to do an analyst review, so we'll give it a title. And we want the analyst to take a look at this incident and either select remediate to reset the user's password and block the URL, or close as false positive to close it down with no further action required. For this, we can set some settings on manual tasks. This applies to either a manual conditional or a regular manual task. For example, we can assign it to specific roles. So if we only want users in our analyst role to be able to complete this task, we can set that and even tell it not to allow anyone else to complete the task. This is useful for things like approvals if you need that as part of your playbook, and the approvers in a different group or business unit, etc. In addition, we can provide details on this task to inform our analyst of the action we're expecting them to take. This task description is markdown friendly, so we'll paste in some markdown. Again, asking our analyst to review the incident, indicators, and either select remediate to block the URL and reset the user's password, or select false positive to close the incident as a false positive. With these manual tasks and other tasks, we also have the option to provide information from the incident or from our context into this task description. So we may want to give them that source username just to be helpful, and we can simply grab that from our incident information. Source username, and that didn't go where we wanted, so we can simply do a cut and paste. And we may want the suspicious URL as well. So we can search for that and add that in here. Hit close, and we can preview what this will look like to an analyst when they are presented this task when working the incident. Okay, so that looks pretty sharp. Obviously, it would replace this from the incident. We can hit OK. Now, to define conditions for a manual conditional, it's as simple as dragging and dropping. So from our half circle, if we select remediate, we'll link it up to our section header, and we're going to give it the name of the path we want to take. In this case, it's what they will be presented when they see this command. So we told them to select remediate, and that'll route it over to our remediation section. Next, if it's a false positive, we can close this down, no further action required. We'll drag this out, we'll call this false positive. Okay. And we'll use the close investigation built-in command to close it down as a false positive. Give it a name, close as false. And we can give it some closing notes. We can fill that out, and then a close reason. You can make the closing notes more descriptive if you'd like. False positive. Okay, this means the analyst, if they choose remediate, will go to the remediation section, or if they choose false positive, it'll close it down. And we don't need an else here because those are the only two options that they're going to be presented. Save our playbook, and then we'll move on to building out the remediation. All right, now that the playbook's there, first thing we want to do is block that suspicious URL. We'll add that task first, dragging it out. We'll call this block URL. And for this, we'll be using another built-in command, which will tag the suspicious URL indicator, allowing it to be added to the EDL we set up way back in video number 1. So in this case, we're going to be using a built-in called Append indicator field, which allows us to add things to the tags and multi-select type fields that are available on indicators. Now this has 3 required options. Again, the indicator values indicates that it's looking for the value of the indicator, IP, or in our case, the URL. We have the field that we want to modify. In this case, we'll be looking at the tags, and then the value we want to add to that field. So let's start. We'll add the suspicious URL in here. Okay, the field will be tags, and we'll be hard coding that. And then the field value is that tag that we're using in our EDL to drop it to the EDL and have XSOAR presented to our firewall. In this case, it was called approved_block, so we can add that in as well. Hit close and OK, and then we can move on to the section about resetting the user. Give our playbook a save. We can use the auto align button to clean this up a little bit, make it look a little bit more straight. And let's add the section to reset the user's password. Now from our remediation section header, we can actually have the block and the password reset happen in parallel. So we'll drag it out so that they both execute. First thing we're going to need to do to reset the user's password is we're going to need to generate them a new password. So let's give this a name, we'll call it generate password. And let's use our generate password automation to generate a new password for them. Select that. We have some different options. We're going to use the default. And you can see that this will return the new password to context. So that looks pretty good. Next, let's reset their password. Drag and drop. do reset user password. And we'll use a command from Active Directory, AD set new password. If we take a look at this command, again using the tooltips, we can see that the username needs to be the SAM account name. We had the email address when we brought the incident in, but we also looked them up as one of the first steps in our playbook. Click the blue curly brace, and we can either grab the username from our task number 1, look up user in Active Directory, and pass in SAM account name, or we mapped that to the SAM account name field as well as part of that task, so we could grab it from either location. Next, we need to specify the password. We can click that here, close, and we'll grab the password that is outputted by our generate password function. Okay, now we're able to reset their password. Now once we reset their password, probably going to want to expire it to force a password change upon next login. Do that as well. We'll do expire password. And we'll use a command from Active Directory, AD expire password. Hovering over to the tooltip, it's going to expire that password. Same thing, we need to present the SAM account name as the username, and we can do that from our playbook editor. Okay, and now we've built the logic to reset and expire that user's password and even generate that new one automatically for us. Lastly, now that we've reset that user's password, we probably want our SOC to give them a call and let them know about it. For this, we're going to use a manual task that's going to require the SOC analyst to complete before completing the playbook and closing the incident. So for this, we'll add a task. Again, we're going to use a manual task, inform user of password reset. And we can provide the details within the task description. Again, this is markdown friendly, so we can give the source username, add that in, and then we can give it the password as well, just so that they don't have to go looking for it. We can grab that from the generate password task. Give this a nice preview, hit OK, maybe actually tell them what to do, call user and provide password. Hit OK, and we can basically link everything out to a done section header. Call this done, which means our playbook is finished, right? And our analyst will then close it with closing notes afterwards. We can link all of our hanging tasks to it, give it a save, give it an align to make it look pretty, and hit save, and we can give it a test. To test our playbook, we can go back to our Playbook Debugger. First of all, we'll remove the override for James Bond, just so that we're not always using him. Now, when doing full playbook testing, a couple things to call out. First of all, the automations and integrations that are executed are actually executed. So in this case, we do have tasks within our playbook that are going to reset a user's password and expire it. Now, if we do not want our playbook to actually perform those actions, we can either set breakpoints, which will stop the playbook before it gets to this task, or we can skip it. So in this case, we're going to skip resetting James's password or expiring the password to prevent it from actually happening. Same thing, we're going to prevent it from blocking the URL for our testing just by highlighting it in the Playbook Debugger. Next, we're going to pop open our debugger panel. In this case, we're likely going to want to test this against an existing incident that we brought in as part of our previous videos. In this case, we can select from the drop-down list, and let's use number 564. And use this to run and test our playbook. Give it a run, and let's see how it runs. Okay, so everything seems to be looking. We can check our work just by looking at the tasks. This was set to high, source IP internal or external. In this case, it was not a 10 dot, so it's a no. And you can see that no suspicious or malicious indicators were found as part of this. So it's going to prompt us for that analyst review. This is how it's going to look to an analyst when the incident runs, so they can choose false positive or remediate to direct the incident as to the response action or just closing it down and being done with it. In this case, let's select remediate because that's a bigger section. Hit mark completed. Let's see how it handles when it goes through the remediation phase. In this case, it generates our new password, but skips the tasks that actually reset and expire it because we don't want to be performing that against James at this time. In this case, it's now telling us to inform the user of the new password. We can see the password here that came from the generate password automation. And with that, we can stop it. We can try it against other alerts within our system to see how it runs. Obviously save it, and then we can review what we did in this video. Quick review. Remember to use that Playbook Debugger to test your playbook as you build it. You have options to override inputs, use existing incident data to test, as well as skip tasks and automations that you do not want it to perform as you build it out. Now in this video, we built out a playbook using a variety of tasks, including manual tasks, which require an analyst to complete the task to advance the playbook. Remember, you can provide instructions in those tasks to your analysts, making the playbook your response process. Next, we use various conditionals that are used to send our playbook down different paths based on incident data or the outputs from previous tasks. We also used a manual conditional, which allows the analyst to choose which direction the playbook should follow for response, remediation, etc. And then we used various automated tasks using automation scripts, integration commands, or built-in commands to work with the incident to advance our playbook. But we're not done yet. Join us in part 2. We're going to further refine our playbook for our use case. And with that, we will see you in the next one.